Hello, this video is about the use of the Flycolor X-Cross 80 A speed controller for aerobatic fixed-wing models. This video covers the capabilities of the speed controller, how to obtain and set up the interface software, and how to configure the speed controller. It also covers some comments and suggestions about its application to F3A aerobatic models. This speed controller is manufactured by Flycolor of Shenzhen, China, and they have a handy English language website. It is intended to be used for multicopters, and it comes programmed with BL-Heli-32 firmware, which also makes it particularly good for aerobatic fixed-wing aircraft. Up to 12 LiPo cells and rated at 80 amps continuous and 100 amps burst. It weighs 66 grams, as I have it here, with leads attached. It uses the latest 32-bit processor chips, which enable it to operate with 32-bit firmware. Why BL-Heli-32? This firmware started life as 8-bit BL-Heli, which was open source. BL-Heli-32 utilises the same very fast motor retardation technology, which is good for precise control of multicopter motor speed. It turns out that this technology is also good for throttle control of aeroplanes, and particularly helpful with airspeed braking using propeller windmilling. I don't know the details of how the technology works, but it appears to do what the firmware developers claim. For a multicopter, it gives faster and more precise manoeuvring response. For an aeroplane, it gives better control of windmill braking and more progressive throttle response when throttling back, particularly for downhill flying. The effect is subtle, but after quite a few hours flying, I am convinced. I use this speed controller for F3A competition aerobatics. Here is my aircraft in case this type is unfamiliar to you. These are quite large, about 2 meters long, with the motors typically being about 3 kilowatts. Why does throttle response and braking matter? Well, for precision aerobatics, maintaining the same airspeed in all directions is a big part of making the flight look graceful and improving the score. This means around the corners and downhill. Stopping the aircraft speeding up when going downhill requires more than just no thrust from the propeller. We need to use the propeller as a brake by allowing it to rotate or windmill even with the throttle closed. The right rotation speed helps to give the right airspeed. F3A aeroplanes need braking in any downward sloping line to maintain steady airspeed, and they are also better to fly if the model slows quickly when the throttle is reduced, particularly in any sort of downward manoeuvre. This firmware seems to give much more braking under part throttle conditions than a speed controller with conventional braking firmware. I have some more detailed comments later when discussing flight setup. Now to setting up BL-Heli-32. The only way to do this is by using an interface which runs on a PC with a Windows, Mac or Linux operating system. The software for this is built into a free issue package called BL-Heli-32 Suite. To connect to the X-Cross speed controller you need an Arduino electronic programming board such as a Nano Mini. These are available from many sources for hobby and educational purposes, but care is needed sometimes to get them to work. So, to downloading the BL-Heli suite, here we go. Search for BL-Heli-32, choose GitHub. This is a good source for a download. Choose BL-Heli-32 zip. Download again, download once more, save file, and after putting the file in a good folder, extract all, extract, and there we have all the files going to where the manuals is. Here's the PDF manual. Back again. Here's the BL-32 executable file. Double click. Run anyway. And here is the interface screen. It will be populated with data after you upload from your speed controller. Also, the fields displayed are likely to change. This exe file does not install anything into the operating system. So to delete BL-Heli Suite, just remove the folder and all its contents. Next, to connect the Nano. This is a Nano. Plug the receiver lead from the speed controller in as shown. Make sure the ground wire is in the fourth terminal from the end. This is marked GND on the board. Leave 3 pins vacant. Now plug the USB cable into the PC. The red light on the Nano will light up indicating power from the PC. My Windows 10 32-bit system automatically installed the driver for it. If you have problems with getting your Nano to communicate with the PC, you will see a message like this when you try to read setup. If the receiver is not powered up and the Nano is OK, you will see this. Nano connection problems are usually caused by not having the right software driver in your PC. Not all Nanos are the same, and many are made with different chips. Alternative software drivers can be downloaded from the internet. My Nano has an Atmel processor chip on the top and an FDTI USB interface chip underneath. The only way I could read each of these was to take a photo using my cell phone with the flash turned on and the chip face tilted at an angle to the camera. Next I connect a battery to the speed controller, at least a 5S. I always like to use a resistor in series with the battery when I'm setting up a speed controller or a motor. This is a 100 ohm resistor with some connectors attached. It should protect against high currents if something is wrong. So now that everything is connected, the BL-Heli32 interface is ready to use. So next we read the data from the X-Cross by clicking on Read Setup. A successful read will be confirmed and some extra fields appear together with the name of the speed controller and the version of the BL-Heli32 firmware being used. The settings in the data fields are the ones that I use for my fixed-wing aeroplane. So starting with the top menu bar, Setup allows you to read and save all the configuration settings to a file. Verify flash memory. This is for advanced users. Select interface. Use option L when your speed controller is plugged into a USB port. Options. I leave the top 2 items ticked to give me helpful information as I go. Information. This lets me read the manual. Saving a screenshot. Very good to save speed controller settings. If you hover the cursor over a field, it will display an information box showing the range and the default value. Also, the icon at the right hand side of each field will restore the factory default values, except for the name field, which is an advisory. Now to the data fields from the top left hand of the interface panel. Name. Use this to label the speed controller which is connected. Ramp up power. I set this at 100% because I control motor acceleration using a throttle servo delay time of about 1 second from 0 to full throttle. This protects the motor from any sudden throttle changes. Temperature protection. If the temperature of the processor chip reaches this value, the motor current will be reduced. My experience is that this is not needed because the speed controller runs quite cool. Low RPM protection. This is also not needed because I use 10S batteries and I want to have full throttle control at low motor speed. Also, my throttle rate of change is quite slow. Low voltage protection. This is intended to provide protection against battery cell voltage falling too low. Unfortunately, this did not work correctly. As I increased the minimum voltage setting, the maximum motor current reduced. I have turned it off. Current protection. This would be a handy feature. Unfortunately, it had no effect, so I have turned it off. Sine modulation. This changes the pulse width modulation to imitate a sine wave amplitude effect. This is intended to improve efficiency a small amount and give smoother motor running. At full throttle, the pulse width modulation reverts to the regular waveform to maintain full power. I have tried this mode, but I didn't notice any difference. Motor direction. This is an important data field. With this you have these options. Normal or reversed are for aeroplanes and bidirectional are for multicopters. Selecting normal or reversed will disable the center throttle setting field, as I have, and provide a normal aeroplane throttle function. Demag compensation. I think this is aimed at multicopters and is not a problem with the usual aeroplane setups. Motor timing. This is an important field and should comply with the motor manufacturer's recommendations. This can be set on auto or manually between 1 and 31 degrees. To increment by 1 degree, just click on the end arrows. Maximum acceleration. This can be set at no limit or a percentage of the throttle travel per millisecond. Again, I set this at maximum and protect my setup with a throttle servo speed limit in my transmitter. Current sense calibration. and auto telemetry are available. Auto telemetry, including current measurement, will depend on the compatibility of your receiver. I'll come back to throttle settings last. Brake on stop. I prefer to have this turned off so that the propeller is free to move at zero throttle and not locked in one position. I think this is intended to stop the folding propeller on powered gliders. Non-damped mode. This will turn off the fast speed reduction and the aerobraking from windmilling. Sometimes turning on non-damped mode is better for aeroplanes, but certainly my application is much better with this turned off. Fast speed reduction and the resulting good aerobraking is one of the things I really like about this speed controller. Stall protection. This protects against propeller lockup due to hitting an obstacle, and it is really aimed at multicopters. Not really applicable to my usage, so I've turned it off. Start up. Beep volume. 30 sounds good to me. Beacon signal volume. This is a lost model find me alert. Again, not applicable to my usage, but could be quite handy. Beacon delay. This sets the time before the beacon starts. Pulse width modulation frequency. This is another important value. This should be set in accordance with the motor manufacturer's recommendation. Music note configuration. This changes the audio tone. Now coming back to the throttle. This is how I do it. First I turn on throttle cal enabled, do right setup to save the changes to the speed controller and disconnect it from the computer. Then I plug the signal line from the speed controller into my receiver with everything turned off. Turn on the transmitter and make sure the throttle output is from -100% to +100%, and that no other mixes or flight modes are affecting the throttle output to the receiver. Turn on the receiver. Push the throttle up to 100%. Connect the battery to the speed controller using a resistor if possible. Wait 3 seconds until rising tones finish. Move the throttle to 0. Wait 3 seconds until descending tones finish. At this point, the initial throttle calibration values have been stored in the speed controller. Now reconnect the speed controller to the BLE32 interface and upload the data values again. Check the minimum and maximum throttle values. The aim is to achieve close to 1000 for the minimum and 2000 for the maximum. If they aren't, then change the throttle travel settings in your transmitter and repeat the process above. Keep doing this until you get close to the target values in the speed controller. Now, the last thing to do, and this is important, turn off throttle cal enable and do right setup again. If you leave throttle cal enable on and you accidentally power up the speed controller with the throttle above 50%, you could lose all your settings. At this point you are ready to power up the motor. So make sure the speed controller is installed with good airflow over the heatsink. Switch on the receiver and the transmitter. Set the throttle stick to 0 and reduce the throttle output to slightly below 0 by using the throttle trim or an arming switch. Connect the load resistor in series with the battery for the initial power up of the motor. The speed controller will cycle through its arming process and be ready to go. Remove the throttle trim so that the stick 0 is 0 throttle. Blip the throttle and check the rotation. If everything is okay, the motor will kick in the right direction. Now remove the load resistor and repeat the startup process. This time the motor will run when you open the throttle. Run up slowly to full throttle while measuring the current. Make sure the motor is running smoothly. Stop the motor by slowing down slowly and check the temperature of the motor and the speed controller. Be careful when throttling back. This speed controller is capable of quite severe braking if you close the throttle very quickly. It is possible to damage the motor or the aircraft. Under test, with the ambient temperature about 25 degrees, the speed controller stayed quite cool, typically about 38 degrees during the standard P21 schedule, and only warmed up to about 42 degrees during landing. The temperature was measured with a contact thermocouple strapped onto the heatsink. You can see on the chart that the downline motor speed was consistently about 2000 RPM with a ground idle of about 1400 RPM. The maximum motor current in the air was about 60 amps. Now, how to set up for aerobatics. This is what it is all about, the ability to control downhill braking as you fly. Change the idle speed and you change the braking. After some trial and error testing with my direct drive outrunner motor driving a two-bladed propeller, I found the following motor speeds at zero throttle to be about right. Take off and normal flight, 1400 RPM. This will give about 2000 RPM in a vertical downline with the throttle closed and a nice response under part throttle conditions. Stall entry before a spin, 550 RPM. During the spin, 350 RPM, and landing, 750 RPM. These speeds will vary according to individual flying styles and aircraft setups. Incidentally, I use transmitter switches, mostly stick position switch combinations, to change flight modes. I set the motor speeds on the ground by activating the switches and then adjust the idle speeds in my transmitter. In summary, I found the Flycolor X-Cross speed controller stayed cool, handled its rated current well, and provided a very nice feel to the throttle control and braking for aerobatic models. At 66 grams, including wires and connectors, it is relatively light. I trust this is of assistance and happy flying to everybody.